Today we're going to analyze the structure of a quadratic equation to determine the most efficient method to solve it, either factoring, completing the square, square roots, or the quadratic formula. So everyone take a look at page 1 and examine the two problems that are presented and see what you find is similar and different about the solutions to these two problems. So hopefully you notice that something that is similar is that square roots were used. And something that you notice that is different for problem B, we needed to complete the square. Now hopefully completing the square is a process you remember from last year in honors geometry. When you did the conics unit, you needed to do a lot of completing the square. So question number 2 is asking us, why was 25 added to both sides of problem B? And the reason 25 was added to both sides of problem B is that it is B divided by 2 squared. It, still high. It creates a perfect square trinomial. And what that means is that it can be factored to two identical binomials. Let's take a look at that again. So if you go and look up on problem B, you'll see that 25 was added to both sides. And when that was done, we had x squared minus 10x plus 25. And that's the easiest method of factoring because it's 1x squared. And so what adds to negative 10 and multiplies to positive 25, well, that's just negative 5 and negative 5. So like the intermediate step that's not being shown here is x minus 5, x minus 5, and that becomes x minus 5 squared. All right, so let's go ahead and flip to the next page. And now we've got two problems that they want us to solve by taking square roots. So the first thing we have to recognize is that we have in problem number 3, we've got isolated 1x squared. This pen is a little shaky. There it goes. Plus bx. All right, and that is a requirement when we are going to complete the square. So now what we're going to do is we're going to take our b value, 14, and we're going to go 14 divided by 2 squared would be 7 squared, which is just 49. So now we're going to add 49 to both sides. And that gives us x squared plus 14x plus 49 equals 72. So now x squared plus 14x plus 49, I want everyone to write the little arrow. This is a perfect square trinomial. I think I spelled trinomial wrong. Yes, I did. Because it's a perfect square trinomial, what adds to 14 and multiplies to 49? 7 and 7. So we can factor this to x plus 7, which I'm never going to write again because it's a waste of time. I'm immediately going to go to x plus 7 all squared equals 72. Now, once I've done that, I can solve this equation using square roots. So I'm going to make a little note. Now, solve with square roots. So I'm going to take the square root of both sides. Boop, boop. and I've got x plus 7 equals, and I need a plus or minus here because it could have been positive root 72 or it could have been negative root 72. And now all that's left to do is subtract 7 from both sides, and I really have two solutions here. I have x equals negative 7 plus the square root of 72, and I also have x equals negative 7 minus the square root of 72. But mathematicians are efficient people, so they're just going to write x equals negative 7 plus or minus the square root of 72. So now we have problem number 4, and problem number 4 is actually easier than problem number 3 because it's already to be solved with square roots. And the way I know that by examining the structure of my problem is that I see I already have my binomial squared in my problem. So I'm just going to go straight to taking square roots, and I've got x plus 15 equals plus or minus the square root of 47, and then I'm going to subtract 15 from both sides. And I've got x equals negative 7 plus or minus the square root of 47. Box of joy. All right, so what I'd like everyone to do is flip to page 3. So now we've got two more problems. We've got Benjamin solved a problem, we've got Corinne solved a problem. And you can see that Corinne obviously used the quadratic formula here. And just as a reminder, everyone must write this down and memorize it tonight. The quadratic formula, if you have forgotten, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That was not the real bell, that was just the bell while I'm recording this video. Don't get up. All right, so everyone must memorize this tonight. Now, that's what Corinne did. She got this lovely answer. Now, Benjamin did not do that, but he also got the same lovely answer. So the question is, what did he do? Well, Benjamin created a perfect square trinomial right here. I'm going to put a box around that. I want everyone to write perfect. Wait, not that one. Right here. Sorry, I was off one line. He created a perfect square trinomial. Okay. So, what strategy did Benjamin use? Benjamin completed the square. Corinne used the quadratic formula. All right, so what strategies did Benjamin's approach have over Corinne's? Well, guys, you're gonna like this answer. There is not much. There's really no advantages that Benjamin's strategy has over Corinne's, but what advantage does Corinne's have over Benjamin? Hers is more to the point. And we're going to start to notice that when we have a situation that is not 1x squared and doesn't factor nicely, that's going to be a quadratic formula problem. Okay? So everyone go ahead and flip to page 4. So now we've got two problems here. And we're actually going to solve both of these problems with the quadratic formula. So we want to remember the quadratic formula, and I'm going to write it down one more time, and then I'm never writing it down again because you will have it memorized. If we have ax squared plus bx plus c equals 0, aka a quadratic in standard form, x will equal negative b plus or minus the square root of b squared minus 4ac all over 2a. If I get back and you don't have this memorized, I fear for your life. Moving right along. First thing we got to do with number 3, and I'm going to do number 3 with you, and then I'm going to do number 4 silently. This is not in standard form. I gotta subtract the 6. So now I've got 5x squared plus 3x minus 6 equals 0. This is A, this is B, this is C. So here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's Pop Go, this is the weasel. I know you love my singing. So negative b plus or minus the square root, so that's going to be 9. Do not pick up a calculator for this. Really. I mean, like, really. You do not need a calculator. It is unnecessary. So let's see. This is 20 times 6. You know we're going to get, this is again just the bell while I'm recording this video. Do not get up. 20 times 6 is going to be 120. And that's going to be a positive 120 all over 10. So I've got x equals negative 3 plus or minus the square root of 129 over 10. And ladies and gentlemen, put a box around it. It is done. Do not touch it anymore. Now, if the square root of 129 reduced nicely, we would reduce it, but it doesn't, so we're going to leave it. I'm going to work on number 4 silently, so don't look up until you have an answer. Again, that's the bell in the video. Sorry about that. If you need more time to work, go ahead and pause the video until you get the same answer that I got. If you are good on problem 4, go ahead and flip to page 5 and you will see Jackie's approach and Sabrina's approach to 2 different problems. Okay, so Jackie's approach, sorry, it's Sabian's approach. I read that wrong. So obviously Sabian's approach is factoring, and you can see Sabian solved this problem pretty lickety-split. Straight into the point. Good job, buddy. And then Jackie, I mean, like, she created a perfect square trinomial here, but this was like a hot mess. I mean, look what went on. She multiplied both sides by 4, and I mean, like, that's a mess. That's a lot of work. Look how much faster Sabian did it, because Sabian looked at the problem and he was like, okay, do I know what numbers add to -7 and multiply to 10? Oh, yes, I do. It's -2 and -5. Good job, Sabian. So the question, what strategy did Jackie use? Jackie completed the square. Which strategy did Sabian use? He factors. Okay. Do we have a preference for one strategy over the other when solving this particular equation? Give a reason. Yes, we do, ladies and gentlemen, and here is our preference. It, makes more sense to factor this problem because it is easy to find two numbers that add to negative 7 and multiply to 10. All right, ready? If, and this is a very important part, key, if a quadratic is written 1x squared plus bx, and b is an even number, then completing the square is an efficient method. All right, so here's the deal. On page 6, we have 4 problems. We are going to solve these 4 problems efficiently. I want you to turn to page 6. I want you to quickly examine these 4 problems and decide what is the best method. Okay. Hopefully you realize that we have one problem right up here. Number 1 is a beautiful factoring problem. Because we can just factor it to x plus 5, x minus 3, and we are done. The end. Simple, simple. Now, number 3, it would be super awesome if this was an even number, but it's not. So I really don't want to complete the square. Instead, I'm going to pick up my old friend, the greatest common factor. I'm going to take out an x. I have 2 things I'm going to set equal to 0. So from x, I just get x equals 0. From x minus 3, I get x equals 3. Now, let's take a look at number 2. Number 2, I got 1x squared. That's easy. But nothing adds to negative 7 that multiplies to 1. That's sad. If 7 was an even number, I would consider completing the square, but it's not. Boo-hoo. So I am left with my last resort of the quadratic formula. Here we go. X equals negative b. Now, if b is negative already, so I'm just negative and negative 7 is just 7. Plus or minus the square root. Now, b squared, be careful, negative 7 squared is 49 minus 4 times a times c. That's easy peasy. All over 2a. And this is a fast problem. 7 plus or minus. Well, 4 times 1 times 1 is just 4. And then 49 minus 4 is 45. And that is over 2. That's bothering me. Now, if you are an awesome superstar, you know that 49 reduces. If you are not an awesome superstar, you're just not an awesome superstar. You know that 49 reduces to 3 root 5. And rock on with your bad self. If you are not an awesome superstar, that is okay. I will accept 7 plus or minus the square root of 45. But if you write 7 plus or minus 3 root 5 over 2, I will think you are an awesome superstar. Problem number 4, do not do this. If you do this and say x equals 5, you will go to math jail. And you will owe me a math jail card. Get out a math jail card. The reason this is illegal is you have lost a solution. So let's try it again. Now, this is what you all have. We're all going to subtract 5x from both sides. And now this problem looks just like number 3. We've got x squared minus 5x equals 0. I'm going to take out the greatest common factor. And I've got x squared Whoops, what's that all about? I got x equals 0 and x equals 5. All right, before I let you loose on your homework, I want you to add a problem number 5. You can probably squeeze it in here, just like cut. You got some extra space here. Let's cut it like right here. All right. We're all gonna add a problem number 5. And here's problem number 5. That's a lot of purple. Let's say we've got x squared minus 8x plus 2. Now let's make it a 3. Equals 0. So this is a good problem. So this does not factor. There are no numbers that add to -8 and multiply to 3. Now, what is in front of the x squared? A 1. And because that is a 1 and 8 is even, this is a great candidate to complete the square. So what's b? b is -8. So we're going to say -8 divided by 2 squared is, let's see, -4 squared is 16. So we are going to, let me erase my thought there. You know, let me write at the bottom because you'll be like, where did the 16 come from? -8 divided by 2 squared is 16. And now I'm going to take that 16. I'm going to add it here. Wait, poop. I screwed something up. Please forgive me. I got so excited about completing the square, I forgot to move the 3. So we've got x squared minus 8x equals -3. Now, -8 divided by 2 squared. We're going to add the 16 to both sides. And x squared minus 8x plus 16 equals 13. Now watch what happens. What adds to -8 but multiplies to 16? If you said -4 and 4, you are correct. So what we are going to do is we are going to write this as x minus 4 times x minus 4, otherwise known as x minus 4 squared. Now we can take the square root of both sides. We've got x minus 4 equals plus or minus the square root of 13, and add 4 to both sides. Ooh, what was that? That was weird. We get x equals 4 plus or minus the square root of 13. I didn't like that there was no example, another example of solving with square roots and completing the square. Ladies and gentlemen, let's summarize, shall we? Write this on the back of page 0. How do we know when to use what method? How do we know when to use factoring? We use factoring when it factors. You need to check all your factoring methods. Can I factor it using greatest common factor? Can I factor it using a equals 1? Can I factor it using difference of 2 squares, etc.? When do I know to solve using square roots? When the problem, let's make it the original problem, is written as a binomial squared, or there is no bx. For example, like let's say we had x squared minus 7 equals 0. We would just add 7 and then take the square root, and it would be like the end. All right, when do we complete the square? When it does not factor, and we can isolate 1x squared plus bx, and b is an even number. If b is an odd number, we get a lot of fractions. I mean, just think about it. If we had a 5 there, 5 divided by 2 squared, nobody wants to deal with that. When do we use the quadratic formula? When it doesn't factor. When square roots are not obvious. I feel like I'm spelling obvious wrong, but I don't care that much. And completing the square would lead to lots of ugly numbers. In other words, it's the last resort. I mean, completing the square is the last resort. All right, homework tonight is page 7. You are to identify the which method is the most efficient, and then you are also to solve those 8 equations. And I'm going to turn the page, and you can see what those are. So here is the homework. Doo-doo. And here are the solutions.